April 1941. The Royal Small Arms Factory, Enfield, England. In the dim light of a converted industrial building, engineers examined a weapon that looked like a plumber's nightmare assembled in a garden shed. The Sten gun, christened from the initials of its designers, Shepard and Turpin and Enfield, was crude beyond belief. A length of steel tubing, a simple bolt, a wire stock, a side-mounted magazine that seemed to defy every principle of balanced design. No wooden furniture, no polish, no grace. It could be manufactured in a bicycle factory by semi-skilled workers using the simplest machine tools. Cost, approximately £2 sterling. Production time, 5 hours. American ordnance officers who examined early examples laughed. The Thompson submachine gun, America's pride, cost $200 and required skilled machinists and precision equipment. It was beautiful, robust, reliable. The Sten looked like something a desperate nation cobbled together from scrap metal, which was exactly what it was. They called it the stovepipe, the plumber's nightmare, the $2 disaster. British troops who received it complained bitterly. It jammed constantly, fired accidentally, felt flimsy, looked embarrassing. Yet by war's end, over 4 million Sten guns had been produced, more than any other submachine gun in history. And those American officers who had mocked it would come to understand a brutal truth about modern warfare. Elegance is a luxury, but simplicity is survival. The strategic situation facing Britain in 1940-41 represented an existential crisis that transformed every calculation about military production. After Dunkirk, the British Expeditionary Force had been evacuated from France, but had left behind nearly all its heavy equipment. Over 500 tanks, nearly 2,000 artillery pieces, and hundreds of thousands of small arms now sat in German hands or at the bottom of the Channel. Britain's army had been saved, but it had been disarmed. The threat of German invasion loomed immediate and credible. Operation Sea Lion, Hitler's plan to invade Britain, was being actively prepared. German forces occupied France, Belgium, and the Netherlands. The Luftwaffe was bombing British cities and industrial centers. U-boats were strangling Atlantic supply lines. Britain stood essentially alone, its army rebuilt from scratch with weapons that either had to be manufactured domestically or imported across submarine-infested waters from America. Military planners faced a mathematics of desperation. Britain needed to arm not just its regular forces but the Home Guard, over 1 million volunteers who would form the last line of defense against invasion. Traditional military procurement could not possibly meet this demand. The Thompson submachine gun, which British forces had begun adopting in limited numbers, was magnificent but impossibly expensive and slow to produce. Each Thompson required approximately 150 machining operations and 25 hours of skilled labor. It was made from high-quality steel, precision machined, hand-fitted, beautifully finished. In peacetime or in a war where industrial capacity was unconstrained, such weapons made sense. But Britain in 1941 faced absolute constraints. Industrial capacity was limited and under constant air attack. Skilled labor was scarce and needed for aircraft production, ship repair, ammunition manufacture. Raw materials were rationed and had to be allocated ruthlessly. Currency reserves were depleting rapidly as Britain purchased weapons and materials from America. The War Office issued a specification that seemed almost impossibly demanding. Design a submachine gun that could be manufactured using the simplest possible production methods, requiring minimal skilled labor, using basic machine tools widely available in small workshops, with production cost under £5 sterling. It should be reliable enough for combat use, but did not need to be durable for decades of peacetime service. Finish and appearance were irrelevant. Weight should be minimized. Parts should be interchangeable without hand-fitting. This specification represented a revolutionary shift in military procurement philosophy. For centuries, military weapons had been crafted objects, made by skilled artisans, finished beautifully, built to last, expensive to produce. The specification for what would become the Sten gun abandoned all of this in favor of one principle: producibility. Major Reginald Shepard and Harold Turpin, two designers at the Royal Small Arms Factory in Enfield, approached the problem with radical pragmatism. They studied existing submachine gun designs, the Thompson, the German MP38-40, the Finnish Suomi, and identified which features were essential for function and which were merely traditional or aesthetic. Their conclusion was revolutionary. Almost everything about traditional submachine gun design was unnecessary complexity. The Thompson's beautiful machined receiver could be replaced with simple steel tubing. The carefully machined bolt could be simplified to a basic cylindrical mass. The wooden stock and foregrip could be eliminated in favor of welded steel wire. The complex blowback mechanism could be reduced to absolute simplicity. The bottom-mounted magazine could be moved to the side, allowing troops to fire from a prone position. The Sten's operating principle was blowback simplicity itself. When fired, the bolt was driven backward by the cartridge's pressure, extracting and ejecting the spent case. A return spring then drove the bolt forward, stripping a new round from the magazine and chambering it. There were no gas systems, no complicated locking mechanisms, no precision timing requirements. It was the mechanical equivalent of a door on a spring. Push it open, it closes itself. The receiver was a simple steel tube with a slot milled for the cocking handle. The barrel was another steel tube threaded into the receiver. The bolt was a cylindrical steel mass with a fixed firing pin. The trigger mechanism was stamped sheet metal. The magazine housing was welded to the side of the receiver at a 90-degree angle, an unconventional placement that made the weapon look unbalanced but allowed soldiers to lie flat while firing. Manufacturing required only basic operations: tube cutting, drilling, welding, some simple milling and turning. No complex machining, no precision fitting, no specialized tooling. Small workshops throughout Britain, bicycle factories, automotive shops, metalworking businesses could produce components. Final assembly was straightforward enough that semi-skilled workers could perform it after brief training. The first prototype was completed in January 1941. Testing revealed numerous problems. The magazine feed was unreliable. The gun fired accidentally when dropped. The simple sear mechanism was prone to failure. But the core concept was sound, and refinements addressed the most critical issues. By mid-1941, the Mark I Sten was entering production. When American ordnance officers first examined the weapon, their reaction was incredulity bordering on contempt. It violated every principle of American weapons design: precision manufacturing, robust construction, reliable operation, long service life, aesthetic quality. It looked like something that belonged in a scrapyard rather than an arsenal. The gap between American and British design philosophy was stark and would become a source of ongoing friction between allies. American reaction to the Sten gun in 1941-42 reflected fundamental differences in how the two nations approached military production. The United States possessed enormous industrial capacity, skilled workforce, advanced machine tools, and abundant raw materials. American military procurement emphasized quality, durability, and performance. The Thompson submachine gun embodied these values. It was magnificently made, superbly finished, highly reliable, and enormously expensive. U.S. ordnance officers examining Stens criticized everything about the weapon. The crude finish, many Stens left the factory with visible tool marks and rough surfaces, offended sensibilities trained to expect mirror-polished bluing and hand-fitted parts. The side-mounted magazine seemed to violate basic principles of weapon balance and handling. The simple wire stock felt flimsy compared to the Thompson's robust wooden buttstock. The stamped sheet metal components looked cheap and temporary. Most critically, early Sten guns had serious reliability problems. The magazine feed system was poorly designed. The single-position feed lips and relatively weak spring meant that magazines often failed to feed properly, especially when loaded to full capacity or when exposed to dirt. The simple sear mechanism meant the weapon could fire accidentally if dropped or jarred. The lack of a positive safety meant soldiers had to carry the weapon with an empty chamber or risk accidental discharge. American after-action reports from British units using Stens in North Africa and early European operations emphasized these defects. British soldiers reported frequent jamming, accidental discharges, and general unreliability. Many preferred to capture German MP-40 submachine guns, which were more reliable despite also being relatively simple designs. The Sten's reputation in American military circles became toxic. It was held up as an example of how not to design infantry weapons. Yet even as Americans mocked the Sten, British factories were producing them by the thousands. By late 1942, production exceeded 20,000 per week from multiple manufacturers. The weapons were being issued not just to British forces, but to Commonwealth troops, resistance movements throughout occupied Europe, Soviet partisans, and various Allied special forces. The Sten was becoming ubiquitous despite, or perhaps because of, its crudeness. What American critics failed to understand initially was that the Sten represented a different philosophy of warfare. It was not designed to be a soldier's lifetime companion or a precision instrument. It was designed to be a disposable tool, cheap enough to be issued in vast quantities, simple enough to be used with minimal training, expendable enough that its loss was not catastrophic. In Britain's desperate circumstances, this philosophy was not just practical, but essential. The mockery would continue through 1942 and into 1943, even as American forces began encountering the Sten's ubiquity in theaters worldwide. The psychological impact of the Sten gun on British troops was initially devastating. Soldiers who had trained with or heard about the Thompson submachine gun, with its gangster mystique, its satisfying weight, its reassuring solidity, found themselves issued what looked like a cheap toy. The Sten's appearance suggested desperation, poverty, industrial inadequacy. It felt like a weapon that Britain had been forced to accept, rather than chose to adopt. Morale problems were particularly acute in units transitioning from Thompsons or other weapons to Stens. Soldiers complained bitterly about the new weapon's unreliability, its tendency to jam at critical moments, its propensity for accidental discharge. Training incidents where Stens fired unexpectedly reinforced perceptions of the weapon as dangerous to its user. The side-mounted magazine made the weapon feel unbalanced and awkward, especially for soldiers trained on conventionally configured weapons. British command faced a significant morale challenge: how to convince troops to trust and use a weapon that looked and often performed poorly. The solution was pragmatic rather than inspirational. Officers emphasized that the Sten was what Britain could produce in the quantities necessary for victory, that perfection was a luxury the nation could not afford, that simplicity meant soldiers could maintain and repair the weapon themselves in field conditions. More significantly, experience began to shift perceptions. Soldiers learned the Sten's quirks and limitations. They discovered that magazines loaded to only 28 rounds rather than full 32-round capacity fed more reliably. They learned to keep the weapon meticulously clean, especially the bolt and magazine. They found that despite its crude appearance, the Sten could survive remarkably harsh treatment. It could be dropped, dragged through mud, immersed in water, and still function after basic cleaning. Most importantly, soldiers discovered that the Sten's simplicity made it uniquely suitable for guerrilla and unconventional warfare. It could be disassembled completely with no tools for easy concealment. Its simple design meant that partisan workshops could manufacture spare parts. Its chambering for 9mm parabellum ammunition meant it used the same cartridge as German weapons, allowing resistance fighters to capture and use enemy ammunition. Its low production cost meant that weapons lost or captured were easily replaced. By 1943, attitudes were shifting. The Sten was still not loved. Few soldiers developed the affection for their Stens that American troops felt for Thompsons, or that German soldiers felt for MP40s, but it was increasingly respected as a practical tool suited to its purpose. The crude appearance no longer suggested inadequacy, but rather purposeful simplicity. American observers began noting this change but largely attributed it to British stoicism rather than any genuine merit in the weapon itself. The mockery continued, even as evidence accumulated that the Sten was proving effective in combat. The revelation that would ultimately vindicate the Sten's design philosophy came not from conventional military operations, but from the shadowy world of special operations and resistance warfare. In occupied Europe, where partisan groups and special operations forces operated behind enemy lines, the Sten demonstrated advantages that had been invisible in conventional military evaluation. The Special Operations Executive, SOE, Britain's organization for conducting espionage, sabotage, and reconnaissance in occupied territory, adopted the Sten as its standard weapon for supplying resistance movements. The choice was not primarily based on performance but on practicality. Stens were cheap enough to be dropped by the thousands, simple enough that civilians with minimal training could use them, and generic enough that they didn't identify their users as British supplied. But SOE operatives discovered unexpected advantages. The Sten could be completely disassembled and hidden in innocuous packages. Its parts could be distributed among multiple people for transport through checkpoints. Partisan workshops in occupied France, Poland, Norway, and elsewhere found they could manufacture replacement parts using basic tools and scrap metal. The weapon's simplicity meant that resistance fighters who had never received formal military training could maintain and repair it. Most significantly, The Sten proved ideal for the kind of warfare resistance movements conducted: ambushes, assassinations, sabotage operations. Its automatic fire capability provided devastating firepower at close range. Its use of 9mm ammunition meant that attacking German supply depots or military posts yielded ammunition compatible with captured weapons. Its expendability meant that resistance fighters could abandon weapons after operations without significant loss. By mid-1943, Sten guns were being dropped across occupied Europe in massive quantities. Tens of thousands were parachuted into France, Poland, Yugoslavia, Greece, and elsewhere. They armed the French resistance, Polish Home Army, Yugoslav partisans, Greek ELAS forces, Italian anti-fascist groups, and countless smaller resistance cells. The Sten became the universal weapon of European resistance, so ubiquitous that German forces began capturing and using them extensively. American Special Operations Forces, the Office of Strategic Services, OSS, initially resisted adopting the Sten, preferring to supply American weapons to resistance groups they supported, but operational realities forced reconsideration. The Sten's low cost meant that far more could be supplied for the same budget. Its simplicity meant fewer supply drops were needed for spare parts. Its compatibility with German ammunition was tactically valuable. By late 1943, the OSS was routinely using Stens for their own operations and supplying them to resistance groups. American operatives who had initially mocked the weapon found themselves relying on it in combat. The crude gun that had been dismissed as British desperation was proving remarkably effective in the most demanding operational environment: guerrilla warfare behind enemy lines. The Sten gun carried emotional significance that extended beyond its tactical function. For British troops and civilians, it symbolized their nation's struggle, not the romantic heroism of propaganda, but the grim reality of industrial warfare waged by a country pushed to its limits. Every Sten represented choices made under extreme pressure. The crude finish was evidence of factories operating around the clock, of skilled workers diverted to more critical tasks, of materials rationed to the edge of adequacy. The simple design reflected engineers forced to abandon aesthetic ideals in favor of stark functionality. The weapon's very existence testified to Britain's desperate circumstances in 1940-41, when invasion seemed imminent and industrial capacity was pushed beyond all pre-war assumptions. For soldiers issued Stens, the weapon was a constant reminder of those circumstances. It was not a tool that inspired confidence through its appearance or handling qualities. It inspired acceptance, an acknowledgement that this was what Britain could provide, that survival required using whatever tools were available, that pride was a luxury when existence itself was threatened. Yet this acceptance carried its own form of dignity. British soldiers learned to be competent with a weapon that required competence, that demanded attention to maintenance, understanding of its limitations, adaptation to its quirks. The Sten sorted soldiers into those who could adapt and those who could not. Veterans who had learned to use it effectively took a certain pride in their mastery of a difficult tool. For resistance fighters in occupied Europe, the Sten carried different emotional weight. It was often the first real military weapon they had ever held, the physical embodiment of Allied support, the tool that transformed them from underground organizers into armed combatants. The crude appearance mattered less to people who had been fighting with hunting rifles, captured pistols, or improvised explosives. The Sten represented possibility, the ability to strike back, to resist, not just passively but actively. American troops who eventually used Stens in special operations developed complex relationships with the weapon. It remained aesthetically offensive to soldiers trained to value precision manufacturing and robust construction. But operational experience taught respect for its practicality. The Sten could survive treatment that would destroy more sophisticated weapons. It could be repaired in field conditions with improvised tools. It could be abandoned without significant loss. This emotional journey, from mockery through acceptance to grudging respect, reflected a larger transformation in how modern warfare understood the relationship between quality and quantity, between perfection and adequacy, between the ideal weapon and the sufficient weapon. By 1944, Sten production had reached industrial scale that shocked even British planners. Over 20,000 weapons per week were being manufactured at multiple facilities throughout Britain. The Royal Small Arms Factory at Enfield, the BSA factory in Birmingham, and numerous subcontractors were producing Stens using production methods that would have been considered impossible for military weapons before the war. The Mark II Steen, the most produced variant, could be manufactured for under $210 in materials and labor. Production time per weapon had been reduced to approximately 5 hours of total labor, much of it semi-skilled or unskilled. Components were made using the simplest possible methods: steel tubes cut to length, holes drilled for pins, parts welded together. Final assembly required no hand fitting. Parts were interchangeable between weapons, allowing for rapid production and easy repair. This industrial achievement represented a revolution in military manufacturing. Traditional military procurement emphasized quality control, precision manufacturing, and individual weapon perfection. The Sten represented a different philosophy: statistical quality control, simplified manufacturing, and acceptable performance across large production runs. Not every Sten was perfect, but the vast majority were adequate for their intended purpose. The production scale had strategic implications that American planners were beginning to appreciate. Britain had armed not just its own forces, but had supplied hundreds of thousands of weapons to resistance movements throughout occupied Europe, to Soviet partisans, to Commonwealth forces worldwide. The Sten had become the standard submachine gun for British and Commonwealth forces, completely replacing the Thompson in most units. More significantly, the Sten's design philosophy was influencing American thinking about weapons production. The U.S. military's M3 grease gun submachine gun, entering production in 1943, showed clear influence from the Sten: stamped construction, simplified design, reduced production cost and time. While American ordnance officers would never admit the Sten had influenced their thinking, the M3 represented acknowledgement that British design philosophy had merit. By mid-1944, American forces in Europe were routinely encountering Steens, carried by British troops, French resistance fighters, Polish units, and various special operations forces. American soldiers could no longer dismiss the weapon as a curiosity or failure. It was everywhere, being used effectively by various Allied forces in the most demanding combat conditions. The production statistics were becoming impossible to ignore. By 1944, over 2.5 million Stens had been manufactured. The Thompson, for all its quality and reputation, had produced fewer than 2 million units over its entire production run. The Sten was becoming the most produced submachine gun in history, not despite its crudeness, but because of the philosophy that crudeness represented. The Sten gun's ultimate vindication came not from any single dramatic event, but from the gradual recognition that it represented a fundamentally different, and ultimately more modern, approach to military weapons procurement. Traditional military weapons design, exemplified by the Thompson submachine gun, assumed that each weapon would serve for decades, that soldiers would be extensively trained on their weapons, that maintenance would be performed by skilled armorers, that replacement was expensive and difficult. These assumptions made sense in peacetime or limited wars where weapons were capital investments requiring protection and careful maintenance. The Sten embodied different assumptions suited to total war. Weapons were semi-disposable tools. Soldiers needed to be armed quickly with minimal training. Field maintenance would be performed by users with limited technical knowledge. Replacement needed to be cheap and rapid. These assumptions reflected the reality of modern industrial warfare, where human mobilization exceeded available skilled labor, where casualties meant constant weapon replacement, where unconventional forces needed arms without extensive support infrastructure. The philosophical difference extended to how the two approaches valued different forms of reliability. The Thompson was designed for long-term reliability, to function consistently over years of service with proper maintenance. The Sten was designed for immediate reliability, to function adequately in current conditions even if it wore out relatively quickly. American ordnance officers, trained in pre-war procurement philosophy, initially viewed the Sten's approach as inferior, but operational experience was forcing reconsideration. The Sten's simplicity meant that soldiers could maintain and repair it in field conditions. Its low cost meant that losses could be rapidly replaced. Its ease of production meant that supply could scale to match demand. Most significantly, the Sten proved that acceptable performance was sufficient for most combat situations. The Thompson's superior reliability and robust construction provided marginal advantages in most engagements. The Sten jammed more frequently, but not frequently enough to make it unusable. Its crude finish and flimsy appearance didn't prevent it from delivering effective firepower at typical combat ranges. By late 1944, American military thinking was shifting. The M3 grease gun embodied lessons learned from observing the Sten's success: simplified design, stamped construction, reduced cost and production time, acceptable rather than perfect performance. While American weapons remained more refined than their British equivalents, the influence of British design philosophy was unmistakable. The Sten had demonstrated that in total war, the perfect was the enemy of the sufficient, that industrial capacity was as important as individual weapon quality, that crude and simple could be effective if properly applied. As the war entered its final year in 1945, the Sten gun's production continued to accelerate even as final victory approached. By this point, over 3.5 million had been manufactured, with production showing no signs of slowing. The weapon had become so ubiquitous in Allied forces that it was simply part of the landscape of European warfare, as common as helmets or boots, as unremarkable as rifle ammunition. American forces advancing through France, Belgium, and into Germany encountered Stens constantly. French resistance fighters who rose to support the Allied advance carried them. British and Canadian troops used them extensively. Polish units fighting under British command were equipped with them. Special operations forces from multiple nations relied on them. Even German units, desperate for weapons as their industrial capacity collapsed, used captured Stens extensively. The final accounting of the Sten's impact required looking beyond its individual performance to its strategic contribution. The weapon had armed resistance movements throughout occupied Europe, providing the means for partisan warfare that tied down German troops and disrupted occupation. It had equipped British and Commonwealth forces with adequate firepower at a cost that allowed universal distribution rather than limited issue to specialized troops. It had demonstrated production methods that influenced weapons design across multiple nations. American military analysts compiling lessons learned from the war could no longer dismiss the Sten as merely British desperation. The production statistics were undeniable. The Sten had become the most produced submachine gun in history. Its simplicity had proven advantageous in operational environments ranging from Arctic Norway to Mediterranean Greece, from Western European hedgerows to Eastern European forests. Its low cost had enabled strategic effects, arming resistance movements, equipping entire armies that would have been impossible with more expensive weapons. More broadly, the Sten represented validation of industrial warfare principles that would shape post-war military procurement. The weapon had demonstrated that in conflicts requiring mass mobilization and extended duration, producibility was as important as performance, that adequate weapons available in vast quantities were more valuable than perfect weapons available in limited numbers, that simplicity enabled logistical sustainability and operational flexibility. By May 1945, as Germany surrendered, over 4 million Sten guns had been produced. The crude weapon that American ordnance officers had mocked in 1941 had armed the Allied victory in Europe. The plumber's nightmare had helped defeat the Wehrmacht. The $2 disaster had proven more strategically valuable than weapons costing 100 times as much. The mockery had not exactly transformed into admiration, but it had certainly evolved into respect. The Sten gun's final vindication came in the chaotic final months of the European War, when its advantages became most visible and its critics most silent. As Allied forces advanced into Germany, they encountered situations where the Sten's characteristics proved ideal. Urban warfare in German cities revealed the Sten's advantages in close-quarters combat. Its compact size made it easier to maneuver in buildings and streets than rifles. Its automatic fire provided devastating firepower at close range. Its simple construction meant that soldiers could repair battle damage using scavenged materials and improvised tools. German defenders, desperate for weapons as their own production collapsed, readily used captured Stens, a backhanded compliment to the weapon's utility. The liberation of concentration camps and discovery of Nazi atrocities gave new meaning to the crude weapons that had armed resistance throughout occupied Europe. The Sten guns dropped to Polish partisans, French maquis, Italian anti-fascists, and countless other resistance groups had enabled active opposition to occupation. They had armed the people who had hidden Jews, sabotaged German military operations, gathered intelligence, and maintained hope that liberation would come. American forces, particularly those engaged in special operations and urban combat, increasingly used Stens operationally. The 101st Airborne used captured Stens during the Battle of the Bulge, when ammunition for American weapons ran short. The Sten's 9mm chambering meant it could use captured German ammunition. OSS teams operating behind German lines in the war's final months routinely carried Stens because of their reliability and the ease of obtaining ammunition from German sources. By April 1945, American ordnance reports were noting the Sten's effectiveness with less dismissive language. While the weapon still had reliability issues and its crude construction remained aesthetically offensive, operational reports acknowledged its utility in various combat situations. The mockery had not disappeared entirely, but it had been tempered by respect earned through combat effectiveness. The final production numbers told the story more clearly than any tactical assessment. By V-Day in May 1945, over 4 million Sten guns had been produced, more than the Thompson, more than the German MP-40, more than the Soviet PPSH-41, though post-war Soviet production would eventually exceed Sten totals. Britain, fighting for its survival with limited industrial capacity and constrained resources, had armed itself and its allies with a weapon designed from first principles to be producible above all else. The crude gun that had been dismissed as a desperate expedient had become the defining submachine gun of the Allied victory in Europe. Its success validated a design philosophy that would influence military procurement for decades. The true climax of the Sten story occurred not on any battlefield but in the recognition, gradual, grudging, but ultimately undeniable, that the weapon represented a revolution in how modern industrial nations approach military production. In June 1945, with the European War concluded and focus shifting to the Pacific, American military analysts compiled comprehensive studies of Allied weapons performance. The Sten featured prominently in these assessments, no longer as an example of how not to design weapons but as a case study in matching design to production requirements. The analysts acknowledged what had been obvious to British planners in 1940 but invisible to American critics, that in total war, the relationship between weapon quality and strategic effectiveness is nonlinear. A weapon of 80% effectiveness produced in quantities 10 times larger than a 100% effective weapon delivers far more combat power. The Sten was perhaps 70–80% as reliable as the Thompson, but it had been produced in numbers that made comparison absurd. More profoundly, the Sten had demonstrated that different operational environments required different weapons philosophies. For conventional military forces with robust logistics and trained armorers, precision weapons like the Thompson made sense. For resistance movements, partisan forces, and rapidly expanded armies, the Sten's simplicity and producibility were more valuable than perfect reliability. The weapon had also validated principles of design simplification that would influence post-war weapons development. The AK-47, designed by Mikhail Kalashnikov in the late 1940s, would embody many of the same principles the Sten pioneered: stamped construction, simplified design, reliability through simplicity, ease of production, tolerance for poor maintenance. The AK-47 would become the most produced military rifle in history, vindicating the philosophy that the Sten had demonstrated at the submachine gun level. American weapons design would also evolve. The M16 rifle, adopted in the 1960s, would use extensive stamped and plastic components to reduce weight and production cost. Modern military weapons across all nations would increasingly emphasize producibility, simplicity, and tolerance for imperfect conditions over traditional virtues of precision manufacturing and aesthetic finish. The Sten gun had been mocked because it violated every traditional assumption about how military weapons should be designed and manufactured, but those assumptions reflected peacetime luxury and limited war. Total industrial warfare required different principles, and the Sten embodied those principles in their purest form. Maximize production, simplify design, accept adequate rather than perfect performance, treat weapons as semi-disposable tools rather than permanent equipment. The mockery had transformed not into admiration. The Sten would never be loved as the Thompson was loved, but into recognition that it had been right for its time and purpose. 70 years after the war's end, the Sten gun occupies a curious place in military history. It is remembered primarily for its crudeness, its ugliness, its reputation for unreliability. Popular culture rarely celebrates it. There are no films where heroes dramatically wield Stens, no iconic photographs where it symbolizes Allied determination. The Thompson remains the romantic weapon of World War II in popular imagination, yet historians and weapons experts recognize the Sten's significance. Over 4 million were produced during the war. a production record that stood for decades as the highest for any submachine gun. The weapon armed not just British forces but resistance movements throughout occupied Europe, Commonwealth forces worldwide, and various Allied special operations units. Its influence extended beyond its service life to shape post-war weapons design philosophy across multiple nations. The Sten's crude appearance and simple construction, which provoked such mockery from American observers, proved to be advantages rather than deficiencies in the context of total war. Its low production cost enabled strategic effects, arming resistance movements, equipping entire armies that would have been impossible with more expensive weapons. Its simplicity meant that partisan workshops could manufacture spare parts, that soldiers could maintain weapons in field conditions, that losses could be rapidly replaced. The weapon demonstrated principles that would become fundamental to modern military procurement, that producibility is as important as performance, that adequate weapons in vast quantities are more valuable strategically than perfect weapons in limited numbers, that design must be matched to production capabilities and operational requirements rather than abstract ideals of weapon perfection. American military procurement learned these lessons, though often without explicitly acknowledging the Sten's influence. The M3 grease gun embodied similar principles of simplified design and reduced production cost. Post-war American weapons would increasingly emphasize producibility and simplicity alongside performance. The mockery of British design philosophy in 1941 or 42 evolved into adoption of many of the same principles by the late 1940s and 1950s. The Sten remained in service with various militaries into the 1960s and continued to appear in conflicts worldwide for decades, a testament to its durability despite simple construction. Resistance movements and irregular forces throughout post-war conflicts used Stens because they remained functional, available, and adequate for their purposes. The weapon's legacy extends beyond its direct military impact to its demonstration that industrial warfare requires rethinking traditional assumptions about quality, cost, and production. In desperate circumstances, Britain designed a weapon that matched available industrial capacity to operational requirements. The result was crude, ugly, imperfect, and remarkably effective at enabling victory.